Okay, here's an example that we can go through of demonstrating hypothesis testing and specifically about an example on population proportions. So there's elections and there's also exit polls. And what happens is that when someone goes in and votes, or right after they voted, someone asks them, hey, would you be willing to let us know who you voted for? And they'll ask other questions also. But they're trying to have some polling, some sample data that they can infer something about the entire election of that day. So they're going to, and there's going to be some people that say no, and then they're not going to be able to ask everyone. So you're always going to have a sample, but we want to infer something about the population. So we've got an election night. People are voting throughout the day, and some of those people are willing and are sampled and are asked if they voted or not and who they voted for. And here's the data. I'm going to just hide that for a second. But here's the data. So we asked someone, they said we voted Democrat, and the other person voted Republican, and the third one voted Republican. And so you could see these are it. So what can we do with those? Because again, all this data are categorical. All you can do is count it. So that's what we've done, and we've estimated some proportions. We had a total of 765 people we polled, and we counted using a count if formula. If you look up there, there's a count if, where the first argument is the range of data, and the second argument you have to put in double quotes since it's text, counting R's. And if you count those, I had 407, and did the same thing with the Democrats, and I had 358. So there is certainly more people who voted Republican, but remember, this is just a sample. We don't care about the sample results. If the sample was the results, then absolutely the Republican won. What we're trying to do is infer something about the population. And is there a big enough difference between these two that we can say, hey, this probably is something we can expand beyond just our sample. So what we do is that we can calculate a sample proportion, and the one we'll use for the class or for the example is that we'll look at Republicans, and you can see that our sample proportion is 0.532. Now that can be converted into a Z statistic, and if you remember, the Z statistic is right here, and so we can calculate if this is 0.532, this is 0.5, 0.5, 0.5, and 760 something. I forgot what it was. So let's go over and look at how we calculated it. 0.532 minus 0.5, that's my numerator. And the denominator, all in parentheses, has the square root. Then your null hypothesis, what you think it is your P. So 0.5 times 1 minus 0.5, all that divided by 765 in the denominator, and that calculates to 1.77. Okay, so that Z value, remember that follows a normal distribution centered at 0, so 1.77 is to the right of that, about 1.77 standard deviations. Well, the question then is that value high enough? And then what is our p-value? That is the area in the tail to the right. The area in the tail to the right. If you remember when we were doing testing error, it is this area here, and in this case it's going to be 1.77. That's what this is, 1.77. This value and this area to the right is going to be what we just calculated. The area to the right is 0.038, which you can see how we calculated that by taking 1 minus and then use the norm dist. Our value on the x-axis or the z-axis is 1.77. The mean is 0, standard deviation is 1. And when you use those formulas, you calculate a p-value of 0.038. So let's go back and put all this in our 7 steps. So our null hypothesis is what we're going to assume to be true is that the Democrat and Republican are equally likely. So the probability that the Republican proportion is 0.5. And we're trying to prove otherwise. We're trying to prove that it's bigger than that, because if it's bigger than that, then the Republican won. We want to be able to have some conclusion that we can state in the news and say that we can call this race. We're going to establish our alpha 0.05. That's just because, again, by convention, it's always something less than 0.1. In the classes I teach, I almost always let students just let that be 0.05. I calculated my proportion from the sample of 0.532. I plug that into my test statistic. In this case, it's a Z statistic, and calculated a 1.77. From that, I calculated a p-value, which is the area to the right of that. It's the probability that the null hypothesis is not true. It's and you can see it's this ought to be 0.038. It's more like it. And since that number, which is small, that number is small, it's less than alpha. Since 0.038 is less than alpha, I can reject the null hypothesis. This is not true. I have evidence to say that's not true, which means this is true. I have evidence that the population proportion is greater than 0.5, so the practical evidence is yes, when the news comes on, we can call a race for the Republican. And that's an example of using of hypothesis testing applied to population proportions. Thanks.